Good afternoon, ladies and gentlemen. I'm delighted to be here. I want to thank the Tencent team for inviting me to this wonderful event. My name is Efi. I spent the last 30 years in developing medical solutions. And today, I would like to talk with you about the future of medical solutions, how technology and software and neurons are going to be combined in order to offer humanity with the next generation of medical solutions. And this presentation will be focused on this concept, and I'll give you some examples. I remember myself as a child at home standing in my kitchen making coffee for my grandmother. She lived with us. She was blind. And I remember that I thought how difficult it is, how terrible it is that a person could not do basic things like eating and drinking and walking, and that she didn't even know how I look like. And when I grew up and I studied and I went into the industry, this thought never left me. Not to be dependent, not to be helpless, but to be capable. And the thought never left me. Today, when we look at the human body, all of us, we want to live a good life. We want to live a healthy life. However, our body sometimes is in the way. It fails us. It gets broken. And our body is a huge, complex, fascinating electrochemical machine. And like every other machine, it gets broken, it needs to be fixed, and parts can be replaced. And we at Rainbow Medical in Israel and many, many other companies all over the world have the awesome job of inventing and developing those medical devices, medical solutions, that can be parts to be replaced or can fix the body. And we have new technologies and we have new frontiers to conquer. We were talking earlier today about design, about materials, about technology, about the combination of bio is the next digital, about how genes and silicon is the next is neurons. We are all seeing this technology coming together. And we do have the technology, we do have the capabilities to manipulate atoms, to manipulate material, to manipulate cells, to manipulate DNA. We have the capabilities to affect people's lives all over the world to make it to the better. And for myself, with my work, I was able to close a circle where in our organization we developed a chip, an artificial retina prosthesis, a microchip-based device that will restore the vision for millions of people in the world blinded by retinal degeneration, like my mother. So this device, the BioRetina, is going to be tested in human very shortly, and I will talk about it a little bit more later. But before we do that, if we want to talk about the road ahead of us, about where we are heading with these technologies, with these products, with the human health, how we can use all these systems in order to improve people's lives, let's look at where we started, how it all started, what was the road made, where we are today, what are the challenges ahead of us in the coming years. It all started, the spare part type of concept, started more than 50 years ago in Minneapolis. A group of engineers identified a big problem in cardiology. The natural pacer of the heart stopped working, didn't function. And they developed a big machine external to the body. You can see it in the center bottom. Big machine that connects on one side to the heart with electrodes and on the other side to the wall for electricity. A pacer is an electrical stimulator, electrical signal sent to the heart to control the heartbeat. in cases where pacer did not work. This device was working and saving the lives of many people. But in 1957, there was a massive power outage in the city of Minneapolis, and many people in the hospitals connected to this pacer lost their lives. And that was the beginning, that was the initiation of battery-operated medical devices. It started then, and since then, Medtronic and many other companies all over the world are developing dozens of implants for dozens of medical conditions. Medtronic is leading the way, that's why I'm mentioning this company, as it has more than 30 different implants in the body, commercially available, to treat a range of diseases like heart failure, Parkinson's, epilepsy, and others. So we have today many implants in the body, but they are so-called blind. They are targeted, they know how to do one thing, and they are implanted to do one thing, and that's it. In the future, we see the body with much more devices implanted, and I will explain the concept a little bit later. Before that, I want to show you one example. A young woman named Sarah, and she was not living a full life. She was deaf. She couldn't hear. And about 3 years ago, she was lucky to have one of the first cochlear implant, a company out of Australia, invented a hearing implant, a device that is implanted in the ear, taking the sounds, converting it to neural language, and sending it to the brain to be recognized as sound. And here you will see the moment that her nurse is activating the device after it was implanted.
There you go. It's beeping. So now technically your device is on. Can you tell? Oh, that's exciting. Here, you can put it down for a second. Just get used to the sound. What does it sound like? Oh, I want to hear myself cry. Can you hear me? And you hear your voice? Does your voice sound pretty loud? No, not really.
Definitely, very, very touching to see this young woman getting new opportunities, new life with one implant that gave her hearing capabilities. And there are many laboratories all over the world, like we heard from Joy and from Walter and from many other people here. There are many, many activities, research and development activities all over the world to try to combine software capabilities, algorithm, testing, diagnosis, sensors, all to come together with biology in order to develop new solutions. Here you can see on the bottom side the hearing implant as it is in the hand of a person, and there are many prostheses and robotics that are more and more connected to neurons to give more opportunities, more capabilities to those spare parts in our body. So I was talking about what we are doing, but still there is a long road ahead. There are still many problems uncured. Alzheimer's, blindness, epilepsy, there are still big problems ahead of us. Even existing medical conditions that they do have a solution or medical device or drugs, they are not necessarily optimized in the solution. It can be better and safer and cheaper. Because the technology today is making huge progress. And if you look, you can see that today's products, if you look a decade ago, it was just fantasy. With technology, With a combination of products and technology and software and materials, you can gain access to solutions that a decade ago were just fantasy. And I look at what's happening around and see that the area of brain research is one of the most booming areas in the world in finances and resources. There are 3 mega projects globally connected that gain access to tens of billions of dollars. And neurosciences, for the next 10 years, we will see exponential growth in knowledge, in understanding, and in practical applicable uses. Other than that, everyone knows that the power of software is getting higher and cheaper. Earlier today, we heard that it cost one fraction of the past cost of sequencing human genome. The prices are going down. The power of software availability going up. The materials, biomaterials, is making huge difference in the way we can put things in our body. So there is a lot of hope and there is a lot of promise by converging these technologies into new medical solutions that will be implanted in our body and treat the problems that we have with new solutions. And there is one thing that is still unbeatable at the moment, but I mentioned brain research, and if you look at brain research, we know a lot about the way our nerve system works at the metabolism part, at the protein level, at the genome level. We know that there is a nerve cell. We know some of the microcircuits that we are studying now. We know very little, almost nothing, about cognition and what makes cognition in our body, in our brain. And the way to understand how genes and cells are connected to cognition. When we explore that, when we unsolve the puzzle, when we know about it, we will know more about where memory is stored, how memory can be retrieved, and new solutions for many medical conditions will be created. But there is still a lot to learn about this area that are significant barriers to the future devices. No doubt, those barriers will be crossed. So, in the future, we see, in Rainbow Medical, we see our body as a machine that we will add implants, sensors. We were talking about, Walter mentioned a lot of sensors that are taking from the outside and collecting data. We will have sensors implanted in our body. We will have stimulation or devices that are therapeutic devices, and we will have drug delivery pumps. When we have these 3 elements in our body, in case we need it, those devices can talk with each other, closed loop, and a sensor identifies there is a problem, it triggers a stimulator that fixes the problem before we even know it. We never know it. The problem is fixed. If there is a sensor that feels that something is missing, the drug is dispensed in the right quantity, there is no attack, there is no crisis, the patient almost doesn't feel anything. That's the future. And in addition to the sensor, to the therapeutic implants, to the drug delivery, there would be some artificial, as I said, replacement part, artificial organs. And here, I would like to give you a few examples. In the case of blindness, many people know that in the past it was the stick, or depending on other people, there are some products in the market that allow today blind people to be a little bit more independent, get some orientation, but the future is the type of implants that the person is not requiring to do anything, like you will see in the device that we are developing today.
Welcome to Nano Retina, whose scientific team from the US, Europe, and Israel aims to restore vision to millions of people blinded by retinal disease. In the United States alone, there are 1.75 million people with advanced age-related macular degeneration, and an additional 200,000 Americans develop AMD each year. There is no cure for AMD, which ultimately renders its victims sightless. Retinal degenerative diseases, including AMD, diabetic retinopathy, and retinitis pigmentosa, are on the rise throughout the world. Today, however, there is hope. Nano Retina is developing an implant consisting of nanoelectrodes, electronic circuitry, photosensors, and IR recipient circuits. This affordable miniature implant is designed to immediately restore vision. Gentlemen, we have the technology. The Nano Retina implant is inserted into the eye in a minimally invasive procedure involving local anesthesia and lasting less than 30 minutes. The implant is attached to the retina, and the implant's electrodes interface with the eye's bipolar neurons. Degeneration of photoreceptors prevents the brain from receiving signals from the eyes, resulting in blindness. However, following implantation, the bioretina converts the image created by the eye's optics to neural stimulation, transmitted via the neural pathway from the ganglia to the brain, thereby restoring vision. The implant's source of power is a wireless infrared beam from specially designed rechargeable eyeglasses. Nano Retina's compact, lightweight system maintains the natural mechanisms of the eye. With the bioretina, patients will again be able to read and watch television. Nano Retina, the restoration of vision, the return of independence and fulfillment. A miracle in the making.
So the Nano Retina technology, thank you. The Nano Retina technology is a platform technology. It is comprised of a microelectrode array that can talk with neuron and convert outside signs, signals into neural language and translate it and pass it through the optic nerve to the brain. We can use the similar platform technology to many other ways to talk and to converse with the central nerve system and with the peripheral nerve system. If we look at other solutions that exist today and will develop into the future for epilepsy, in the past there were drugs and just holding the person during an attack. Now there are in the market stimulators of the vagus nerve, and the patient need to feel it and then switch it on. And in the future, there will be some sensors, and the activation will be automatic, and the patient will not intervene. It will prevent the attack long before it happens. Similarly, paralysis, very debilitating condition, making people depending on wheelchairs. Now there are certain products that are mechanical skeleton for paralysis people that are able to stand and do certain activity at the same height. And this is very important for them. And in the future, there will be neurons and stimulators that will be connecting back certain areas that will allow people to restore motoric capabilities. If we look at the most terrifying, debilitating condition that is unsolved yet is Alzheimer's disease. Is very difficultly affecting many families, not only the person who is suffering from that, but the whole circle, the community, the people around him. Here, there are still no solutions. We are working on a device that will be implanted in the head to be able to prevent the disease from progression. But the future is to understand where the memory is, be able either to replace it or to fix it or to open new channels for the memory to get to cognition, bypassing the areas that are dead, that are part of the Alzheimer's disease. So the industry is going to be based on the convergence of many, many technologies, many, many capabilities in order to develop the future medical devices. And it will require lots of funding, but mostly many brilliant people like you guys that will be willing to dedicate their lives to inventing those medical devices. And the industry needs brilliant people that are willing to dedicate their time for a long, long time in order to make it happen. And you're all welcome to join this exciting journey. Thank you.